Why was coding, rather than art, science, or conversation, the first major field where AI achieved breakthrough capability? The common assumption is that programming is somehow easy for AI, but the reality is more nuanced. For years, programming was thought to be one of the hardest jobs for AI to automate. It demands logic, creativity, and expertise. Yet, AI now writes, debugs, and even builds apps. Why did coding fall first? The answer lies in a concept called asymmetry of verification. Take Sudoku as an example. Solving the puzzle can take a long time, but checking a completed solution takes just a moment. This gap, the difference between how hard it is to solve versus verify a problem, is everywhere, and coding is no exception. Verifier's law explains it clearly. The ease of training AI to solve a task is proportional to how easy it is to verify the answer. In coding, checking correctness is fast, objective, and automatable. Test cases can instantly show whether the code works. Results are clear, either it runs or it doesn't. Errors are flagged automatically. AI thrives in these environments where feedback is immediate and unambiguous. Compare this with tasks like essay writing or scientific discovery. Fact-checking an essay can be harder than writing it. That's Brandolini's law in action. Verifying a new theory or diet could take years of experiments and still remain uncertain. Such tasks are hard to verify, making them much harder for AI to master. Coding offers billions of examples and endless opportunities for rapid trial and error. Automated tests give instant feedback, so AI can quickly learn what works and what fails. Where humans take years to build coding intuition, AI can iterate thousands of times a day, always getting measurable feedback. The real secret isn't that coding is simple, but that it's verifiable. If a task can be measured and evaluated at scale, AI can optimize for it with incredible speed. Before moving on, let's pause and consider another field that's made headlines for its AI breakthroughs: natural language processing, or NLP, the technology behind models like GPT. For a long time, NLP was actually seen as one of the hardest areas in machine learning. The reason is fundamental. Unlike coding, NLP doesn't have obvious ground truth for most tasks. To train AI to understand language, you need vast amounts of labeled data, millions of human annotated sentences, translations, or summaries. These labels aren't easy or cheap to produce. In fact, they often require domain expertise, years of work, and huge expense. In most NLP tasks, there's no clear right answer that a computer can check automatically. Is this sentence a good translation? Does this paragraph summarize the main idea? The only way to know is by asking a human, and humans don't always agree. That's why progress in NLP was so slow for decades. Even now, despite the power of models like GPT, further breakthroughs demand ever more data, high-quality labels, and increasingly sophisticated benchmarks. The same Verifier's law applies here. If the ground truth for a task can't be generated or checked automatically, it becomes much harder for AI to improve rapidly. This leads to what some call a jagged edge of intelligence. AI will excel in fields where answers are easy to check, but struggle where verification is slow, subjective, or complex. Whenever AI masters coding or similar tasks, it's not just about intelligence, it's about the clarity and speed of feedback. So what's next? Which domains will fall to Verifier's law, and which will remain human for longer? Let's keep exploring. Subscribe to Incomplete Intelligence as we follow the ever-shifting boundaries of AI and human capability. Like, comment, and share if this made you think differently about AI's progress. See you next time.